Ladies and gentlemen, I'm standing here in the United States Museum of the Air Force here in Dayton, Ohio. And one of the things we want to talk about is anytime we're talking about geometry, we're talking about angles. And this right here behind me is an F117. It was a Nighthawk program, paved blue, or half blue, excuse me. And you'll notice something about this. This is a stealth aircraft, but it doesn't look at all stealthy because of all these weird angles all over it. The whole point of this aircraft is as radar comes in, what it does is it's intended to hit a panel and bounce away rather than being sent back. Because if you take a look over here at an F4 Phantom, this has a rounded fuselage, traditional fuselage that we're used to. Anytime you have a rounded surface, at some point, there's going to be a point on that curve that is literally perpendicular to the radar. So the more areas that you have that are perpendicular to the radar, the more signature is sent back to that radar. So the whole goal of this item right here was so that when radar hit it, it would bounce away. Even if you have open doors, although that was always a problem, you'll notice that the armament here is in a closed hatch, and that closed hatch does not have a straight front on it. It's like a serrated front. Or the same thing on the nose door, you have this point. Everything on this was meant to bounce radar away at an obtuse or oblique angle rather than sending it back to wherever the radar was coming from. So angle of incidence equals angle of reflection, and angles here what give this its stealth.